discussed about the different terms which we are going to use in the coordination compounds. In the today's class, we are going to study the nomenclature. Very important thing. The nomenclature of coordination compounds. So this nomenclature is compulsory question for 1 mark students. Okay. So in this, listen, before going to say the rules, how to write the name of the compound, as like you know the IUPAC name for the organic compound. Similarly, there is a IUPAC name for this name nomenclature rules for this coordination compounds also. Before going to tell the name, the rules, so I will give you some tables of ligands and the different metals and what are the suffix they follows, what are the prefix they follows. Okay. So first, name of ligands. Name of ligands. You know, ligands are of two types. One is neutral, another one is anion. Okay. Negatively charged species or neutral molecules are said to as are told as what? That ligands. So in the name of the ligands, I will go with the ions now. Okay, negative ions. Assume the first one is CH3COO minus. If this ion is there in the complex, then the name in the complex is acetate. This chart is very important, student. Keep on writing this and keep it the table with you while you write in the coordination compound. If CH3COO minus is there, that is acetate ion. Last E. Acetate means E, right? Last E is replaced by what? O. Acetate, that last E is replaced by O. Remember that. Acetate. So next, NH2 minus. So NH2 minus means what? That is amide. Amide group. So here what happens? This last E is replaced by O. That is amido. So if it is in the complex NH2 is there, then it is named as what? Amido. Next, Cl minus. That is chloride. Okay, F minus fluoride, I minus iodide, Br minus bromide. Understood? So the next one is HS minus, that is hydrogen sulfide. This is hydrogen sulfide. Hydrogen sulfide. Next one is Cn minus, that is cyanide or cyanide. Okay, next. NH2 minus is there, that is called as imide. So imide. Imide is there, then it is called as imide. Next, NCS minus is there, iso thiocyanide or iso thiocyanone. Okay, next, if SCN is there, then thiocyanide. Okay, if NO2 minus is there, students, then it is nitrate, nitrito N. If ONO minus is there, then it is nitrito O. So these are the anionic ligands. So ions with a negative charge. Understood? Minus. And another one is there, O2 minus. That is oxido. If you want to write another one, that is OH minus hydroxido. Hydroxide, that means hydroxido. So students, what you are going to write? Last T after all the elements, last T after all these anions are replaced by what? O. Okay, so this is here also. Nitrite, nitrito, oxide, oxido. Okay, so this is the one. The name of the ligand, if they are negatively charged. If ions are there, then they are named as this. So another one is there that those are what? Neutral molecules. If the neutral molecules are there, then how they are named? Ligands with the neutral ligands. What are the neutral ligands? H2O is there. Okay. NH3 is there. NH2, CH2, CH2, NH2 is there. C6H5N is there. Now C6H5. Okay, this is C5H5N. C5H5N is there. Okay. PH3 is there. Means 6H5 thrice. Okay, and EDTA is there, ethylene diamine tetraacetate. If you want to write the structure, CH2, CH2, N, CH2, CO minus. CH2, CO minus, CH2, CO minus. So these are our what? The neutral molecules. So another one is there, right here. First, this is named as aqua. This one is named as amine. Remember, AMMINE. That is very, very important. Don't write AMINE. That amine means RNH2 compounds. So this is amine. So here NH3 ligands means that is AMMINE, amine. We have to remember, if we left one M means we will lose complete marks. Understood? This is very, very important. AMMINE. This one is ethylene diamine or ethane 1,2 diamine. Ethane 1,2 diamine. Next, this one is pyridine. Next, triphenyl phosphine. Triphenyl phosphine written as PPH3. Okay, this one is EDTA, ethylene diamide tetraacetate. So another two are there, students, neutral molecules, that is CO, carbonyl, named as what? Carbonyl. Okay, and NO, that is nitrosyl. Carbonyl and nitrosyl, those are our what? Neutral ligands. Understood? So these are all name of the compounds in the negative ligand, negatively charged ligands, and those are our what? Neutral ligands. So if in the complex these ions are there, the name of the ions in the ligand for in the complex follows this order. Not like that. Chloride, fluoride, iodide, they are formed as chloride, amide, oxidation, like this. Okay, so this is all about ligands. Similarly, name of this chart is very important to write the nomenclature name of the compound, students. As I told you, please note down the table and keep it outside while naming the compounds. You compare while I am writing name with this table, then you easily understand what it is. Okay. So name of the metal. Okay. So metal, cationic complex, anionic complex. Okay. So here what happens? For example, ions. If Fe is there, if it is dissociates as a cationic complex, means a coordination sphere with a plus charge, then it is named as iron. If it is dissociated as a negative complex, then the name is ferrate. Okay? If cobalt is there, cationic complex, that is cobalt, anionic complex, cobaltate. Okay? If chromium is there, this is chromium, this one is chromate. Nickel is there, here it is nickel, here it is nickelate. Next, here it is gold, here it is orate. If Hg is there, here it is mercury, here mercurate. Okay, so platinum is there, here platinum, here platinate. If palladium is there, it is palladium, this is palladate. Okay, similarly, if Sn is there, here it is tin, here stannate. Okay, Ag is there. Here it is silver. Here argentate. Okay. Certain is there. Here it is zinc. Here it is zinc. Similarly, student, as I told you, if any metal is there, if it is dissociated as a cationic complexes, then the name of the metal is as it is like a metal atom. If it is a neutral or cationic, the name of the metal follows the iron, cobalt, chromium, nickel is the same, cationic or neutral. Okay. Next, if anionic carbon, NEU, neutral. If anionic are there, the complex is dissociated as an anionic complex, then the name of the metal ends with the suffix ATE. Wherever you see the last term or the name of the metal at the end have the suffix ATE. Okay. So I'll give one example. For example, K4 Fe Cn6 is there. If you dissociate, you will get 4K plus Fe Cn6 4 minus. So students, here it dissociated as what? Anionic complex. The complex is an anion. So here what happens? First, the name of the compound follows potassium hexacyano ferrate 2. Remember, just now I wrote the name, so you will understand easily. If it is FeNH3 6 times Cl2, then it is dissociated as FeNH3 6 times 2 plus 2Cl minus. Okay, then it is hexacyano iron 2 fluoride. So here it is a cationic complex, so it gets the name iron. Here it is an anionic complex, so it gets the name ferrate. So this is cationic iron, anionic ferrate. This is the way to write the nomenclature. So many rules are there. Just to remember what happens to what is the name of the atom in the different types of the complexes, cationic, neutral, as well as anionic. Once we know this, then we are going to know the name of the complexes. The rules to write the complexes. So students, as I told you, like anionic ligands, cationic ligands are also there, like H3O plus and NO3 minus, like that. So those are ends with what? Hydronium ion, nitronium ion. So last two, like IDE is replaced with IDO. In anionic species, E is replaced with what? O. Similarly, in cationic, it is the suffix follows IUM. Nitronium, hydronium, oxonium, like that. Okay. Next, rules. Rules to write the name of the compound, especially coordination compound. Okay. First rule is, students, order of naming. Here, cationic species named first. Cationic species named first. In the below example, I wrote here for potassium K for Fe6, I wrote potassium plus first. Okay, so like potassium hexacyanoferrate. So in the second, I wrote complex first because complex is the cation. Whatever the species it is, student, whether it is a complex or a neutral molecule, complex or a counter ion, the order of naming is cationic species named first. Okay, whether it is a complex or a counter ion. The which one have the plus charge, that is named first. And the second one is naming of the coordination sphere. So first one is order of naming. Second one, while naming of the coordination sphere. So what it follows? Name of the ligands in alphabetical order. First one, name of the ligands in alphabetical order. Correct? Next, name of central metal atom. Okay. Next, oxidation state of metal atom written in Roman letter in a bracket in an open bracket. This is the rule to name the coordination sphere. First, we have to name the respective ligands with respect to the alphabetical order. For example, amine is there, Cl is there, OH is there, and NO2 is there. So here, this is students amine. Correct? This is chloride. This is hydroxide. And this one is nitride. So according to alphabetical order, which one comes first? Amine, chloro, hydroxide, nitro. So the name, by naming the name of the ligands, first amine is named. If it is 4 times, then it is tetraamine, like that. Next chloride, next hydroxide, next nitride. So the name of the ligands is named according to the alphabetical order. First, next, name of the central metal atom based on the complex, whether it is an anionic complex or a cationic complex, then we have to write the name of the compound. If it is a cationic complex, then the metal is named as, if iron is there, iron, cobalt is cobalt, or nickel, like that. Okay. If it is a cationic complex, if iron is there, then it is named as ferrate. For nickel, nickelate. For cobalt, cobaltite, like that. Okay. That's name of the central metal atom based on what? The cationic species or an anionic species, or a cation or an anion charge, which is pairing by what? That coordination sphere. Next, oxidation state of a metal written in Roman letter. This is very important, students. How to calculate the oxidation number? As I told you, I gave you a list of ligands, right? So in that neutral ligands are also there, and also anionic ligands are also there. So I'll give one example how to calculate the oxidation number. So listen, cobalt is there, NH3 3 times, H2O 1 time, Cl2. Cl. This is the one thing. Okay. Students, what you have to do, similarly in KMNO4, how you are going to calculate? Like 1 into K plus, for 1 into K plus 3 into Mn plus 4 into oxygen. Similarly here, 1 into cobalt plus 3 into NH3 plus 1 into H2O plus 1 to 3 into Cl atoms. Correct? So here cobalt is X, we don't know, plus 3 into NH3 is a neutral molecule, so it is 0. H2O is also a neutral molecule, it is also 0. Plus 3 into minus 1. So X minus 3, so this is equal to 1? 0, because net charge is 0 here. 0, X is equal to plus 3. So oxidation state of cobalt in this complex is plus 3. This is the way to calculate the oxidation state. Okay. So similarly, if the complex is with the charge, that is Fe, Cl, Cl6, 4 minus. Okay, so 1 into iron plus 6 into Cn is equal to how much charge? Minus 4 charge. This is the net charge on the complex. So Fe plus 6 into minus 1 is equal to minus 4. Fe minus 6 is equal to minus 4. Fe is equal to plus 2. So here plus 2 is the oxidation state of iron. So this is the way to calculate the oxidation number. So what is oxidation number, students? I'll write here. Oxidation number in coordination compound. Okay, so it is the net charge on the central metal atom when all the ligands are removed with their electron pair shared by metal atom. So this is the oxidation. It is the net charge of the central metal atom when all the ligands are removed with their electron pair shared by metal atom. So that is called what? Oxidation state. So here CO is there, and right here, and from this. So this is CO NH3 3 times, H2O 1 time, so H2O 1 time only, Cl 2 times, Cl. So first remove this, students, then you will get CO NH3 H2O Cl2 minus 1 charge. Correct? Then remove these two, that is CO NH3 3 times H2O minus 3 charge, because 2 Cl are already minus 1 is there, again minus 2 left means that is minus 3 charge. Next CO NH3 3 times with minus 3 charge, because this is 0. And finally, CO with the -3 charge, if NH3 also removed. Okay, so this is what oxidation state. It is the net charge on the central metal atom when all the ligands are removed with their electron pair shared by this metal atom. So this is what the oxidation state. This is the way to write the oxidation state, student. So if oxidation state 3 is there, as I told you, that is written in one Roman letter like 2, 4, 3, 6, like that. Understood? So the oxidation state of the metals are written in the open bracket with this Roman letters. This is the rule to write the name of the complexes. Okay. Next one is third one is numbering of ligands, that is prefixes or number of ligands. So students, as I told you, the number of ligands always follows. If mono is there, nothing to worry, directly write the name of the ligand. From second, if two number is there, is to di, tri, tetra, penta, etc. Okay, so numbering of ligands, the prefixes for number of ligands is di, tri, tetra, penta, etc. If the ligand itself consists of already a number, okay, if the ligand itself, for example, NH3 6 times is there or NH3 3 times is there, amine, there is no number, so this is triamine. Okay, instead of this, you take ethan 1,2-diamine. Okay, so students, in this already ethan 1,2-diamine is there. Di already comes in the name of the compound. So then what happens? If the ligand already consists of the prefix like di, tri, tetra, then it follow the prefix bis, tris, and tetra case. Okay, then it follows bis, tris, and tetra case. So students, here what we are going to see? Okay, correct. So this tris and tetra case is there. For example, E 2 times is there, that is written as bis ethane 1,2-diamine. Understood? If PPH3, that is triphenyl phosphine, 3 times is there. If it is 3 times is there, it is not written as, you may take like this, 3 times. So the name itself as triphenyl phosphine. Understood? It is 3 times. Okay, it is not written as triphenyl phosphine. So then it is written as tris triphenyl phosphine. So understood? If the amine or a ligand or any ligands which doesn't contains any prefixes before like di, tri, tetra, so then they follows the prefixes di, tri, tetra, penta, etc. Okay, if the ligand name already consists this type of prefix first, like ethane 1,2-diamine is there and PPH3 3 times is there, so then what happens? It contains di, it contains tri, means it follows base ethane 1,2-diamine and tris triphenyl phosphine. Understood? This is the way to write the number of the complexes. So this is all about the rules, students. What are the rules? First one, order of naming, whatever may be the order, the name of the species or the cationic species named first, whether it is a counter ion or a complex. So the naming of the coordination sphere means first name of the ligand, they based on what? Neutron bulk, as I given the list before, students. So if number of ligands are there, in that ligands anionic species is there, cationic species is there. Correct? So if anionic is there, then the name ends with what? IDO, right? If the name of the central metal, again complex anionic is there, cationic is there. Based on that, the name of the metal and then oxidation state. What is oxidation state? It is the net charge on the central metal atom when all the ligands are removed with the electron pair shared by the metal atom. So once we know the oxidation state and the ligands, and then we have to write the number of the ligand. Numbering of the ligands is done in this manner: right, tetra, penta. If they didn't consist of any number of or any prefixes like right, tetra before, okay, and previously in the name. So example for those is ethane monodiamine, triphenyl phosphine. If this type of complexes are there, then they are named as. Then the prefixes follows bis, tris, and tetraphase. Okay, so this is all about the name of the nomenclature. You remember these three things. So I write some of the one or two formulas here, and I explain how to write the name of the complex. Then you came to know easily. As I told you, students. Okay. So listen. And here, CO, NH3 2 times, H2O 2 times, Cl2, Cl2, Cl. Okay, next. K3, K3, CO, NH3 2 times, Cl 2 times, times oxidation. This is we just remember C2O4 twice. Okay, so students, if we want to calculate the oxidation state first, so cobalt is there, X plus 2 into NH3 means 0, plus 2 into this hydrogen H2O means 0. These 3 Cl atoms are there, minus 1, that is equal to 0. Correct? So x plus 0 plus 0 minus 3 is equal to 0, x is equal to plus 3. We have oxidation state of cobalt in this complex is plus 3. Similarly here, potassium is there, 1 into potassium, that is plus 1. Cobalt we don't know, x plus 2 into amine is 0, it is minus 2, that is equal to 0. Oxalate ion C2O4 2 minus. So here it is plus 1 plus x plus 0 minus 4 is equal to 0. X minus 4 plus 1 is equal to 0. X is equal to plus 3. Here also it is plus 3 oxidation state. Okay. So this is the first thing we remember already. So we got already the oxidation state of this compound. Okay, from where we will get this charge? I given the table. This is neutral molecule. This is the anionic species. From there we will get the charge of the ion. So then, what is the rules first? If you dissociate this, it is dissociated into what? CO, NH3 2 times, H2O 2 times, Cl2 plus Cl minus. So this is dissociated as what? Cation. So here K plus CONH3 2 times C2O4 twice minus 1. So this is not minus 1, this is 1 minus 1 plus. Always the name of the first, the charge of the ion, the numerical followed by the sign. Okay, this is also a rules. Writing the name, it is not plus 1, it is 1 plus. First number we have to write followed by the sign. Here students, first we got the cationic complexes. Okay, so in this, the name of the coordination sphere is ligands are named first, followed by this cobalt, name of the metal with the oxidation number. So listen, here this is amine, this is aqua, this is chloride. This is as it is in the alphabetical order. So how many times is there? 2 times is there. So 2 not 2, sorry, this is diamine, correct? This is completed. Next, aqua. Next, dichloride, correct? So ligands are completed. Then followed by this cationic species means as it is cobalt, oxidation state is 3 and the counter ion is chloride. So this is diamine, dialco, dichloride, cobalt 3 chloride is the name of this complex. So students, remember one thing, always the name of this is in small letter and there is no gap between any word. Understood? So diamine, dialco, dichloride, cobalt 3 chloride, there is no gap between the words. This is also a rule to write the name of the complex. Understood? There is no need to left the gap. If you left the gap, like if you write diamine, dichloride like that, you will lose the marks. Understood? The name should be continuous. There is no gap between any letters. And at the same time, we have to write complete diamine, A-M-M-I-N-E, remember. Okay? And all are in small letters only. So if you want to write here, students, which one is the complex here? Potassium. That is cationic complex. Potassium, this is small letter only, okay? Potassium, next name of this sphere. In the name of this sphere, this will label first. Diamine. Okay? This one is dioxalato. Correct? Here cobalt is there. Anionic complex means cobaltate. Oxidation state is 3. This is the way to write the name of the complex. In the tomorrow's class, we will discuss with so many compounds name. I will give a set of this type of formulas and keep on writing the name. You will came to understand, students. While I wrote that,